to graph quadratic functions. In Vertex or Intercept form. So just as a refresher from the notes, Vertex form is y equals a times x minus h squared plus k, and intercept form is y equals a times x minus p times x minus q. For the first one, the vertex is at hk. And it has to be in this order. So like the negative sign, if this isn't negative, then you've got to change the sign over here. And if this is not positive, then you've got to change the sign over here. Your axis of symmetry for the first one is at x equals h. For intercept form, we do it a little bit different. We find the intercepts, so the x-intercepts are at p and q. Again, if these signs don't match here, then you have to change the sign on your intercepts. And then your axis of symmetry is halfway between those values, so it's at p plus q over 2 would be where your axis of symmetry is. And same stuff applies. If it's like positive, it opens up. If it's negative, it opens down. Your vertex you find by plugging in this point and solving for y. Let's look at some examples, starting with vertex form. So number 6, got y equals 3 times x minus 7 squared minus 1. So my vertex, so this is just like my a times x minus h squared plus k. So these signs match up, so I copy down the 7 for my x value. These signs don't match up. It's supposed to be plus k, this is a minus, so that means that we have to change the sign of our k value, so it's going to be -1. So the way I was telling pre-cal to remember it the other day, because we were doing this in there, was I said whatever sign is here, I said it's opposite down here. So whatever sign is here, it's the same one down here. So h is opposite, k is the same. So my axis of symmetry would be where? It's always going to be wherever the x value of your vertex is. Okay. And is this one going to open up or down? Up. Yep. Opens up. So we can set up a graph. Now this one, obviously it's got an x value of 7, so I'm going to make my graph like pretty heavy to this side. So I'm going to draw in my axis of symmetry at x equals 7. My vertex is at 7, -1. So then I just need to find another point that is on the graph. So I'm going to use 8 because that's 1 away from my axis of symmetry. So if I plug in 8, you have 3 times 8 minus 7 squared minus 1. So 8 minus 7 is 1. 1 squared is 1 times 3 is 3. So then 3 minus 1 is 2. So at 8, we have a point at 2. And then that's 1 away on the right. So if we go 1 away on the left, we have a point in the same spot.
Wait, I'm confused. How much did we go up?
So I plugged in 8, so that was 1 away from the axis of symmetry. Words are not working. So I plugged in 8 for x up here in this original equation, and so then that gave us 2. So it's up to 2. Let's see, number 8. Y equals 2 times x plus 1 squared minus 3. So where would my vertex be for this one? -1, -3. So opposite sign inside, same sign outside. So my axis of symmetry is where?
-1.
Yep, x equals -1.
Just kind of walked.
You made it.
Sorry. Decided to
And-
teach school. Yeah, I guess. Maybe just one day.
Does this one open up or down?
I say up.
Opens up.
Yeah, so smart. Riley just came. Literally just because it wasn't positive. Or no, because it is positive. Maybe we just trying to dominate. Yeah, go on. Gotta start strong.
Basically.
Yeah, okay.
Just a different form. We did standard form yesterday. We're doing vertex form and intercept form today. So we're on our second example for vertex form. All right, so I have an axis of symmetry at x equals -1. So I'm going to draw in my dotted line for that. I have a vertex at -1, -3. So since 0 is 1 away, I'm going to go ahead and use 0 because it's easy. So 2 times 0 plus 1 squared minus 3. So it's going to be 1 squared is 1 times 2. So I have 2 minus 3, which is -1. So I'm putting a point at 0, -1. That's 1 away on the right. So if I go 1 away on the left, I have one in the same spot. And connect the dots. Vertex form is probably my favorite. It's the one that requires the least amount of work. A little bit more memorizing, but less work. Number 10. So one more in vertex form. We've got y equals -1/4 times x plus 2 squared plus 1. So where's my vertex? -2, 1. So opposite sign inside, same sign outside. Axis of symmetry. x equals -2. And then opens up or down?
Down.
Opens down because it's negative. So then we're going to graph it. So I've got an axis of symmetry at x equals -2. So I'm going to put my dotted line there. A vertex at -2, 1. So it's up here. Got to remember it opens down. So I just want to keep that in mind. Our points now should be at the bottom. So I'm going to do... I'm going to do 0 because it'll make things cancel better. So I'm going to use 0. It's only 2 away, so it shouldn't give me a ridiculous point. So plugging in 0, I've got y equals -1/4 times 0 plus 2 squared plus 1. So inside of the parentheses, I'll have 2 squared, which is 4. So -1/4 times 4 plus 1. So the 4's cancel. -1 plus 1 is 0. So 0, 0 is going to be one of my points. So just notice it's still below. It's just going to be a wider opening. So I was 2 away on the right. If I go 2 away on the left, okay, now the number in front here, this -1/4, that's what makes it so wide. Okay, it being a number less than 1, not, let me rephrase, an absolute value being less than 1. Okay, meaning it's a decimal or a fraction is what makes it wide. All right, let's move to, or well, do we have any questions about this form?
How are we finding the vertex, like the x?
So it's in this form, so x minus h squared plus k. So the vertex is at hk.
Okay.
But it's got to be in this, so I say whatever the sign is inside, it's going to be opposite over here. So if it's negative, it's going to be positive. If it's positive, it's going to be negative. Outside, it's the same sign. So, and then the axis of symmetry is just wherever your x value is. Any other questions on vertex form? I'm ready to move to intercept form. All right, intercept form. Still think intercept form's a little easier than standard form, but there's a little bit more work required. Let's look at 14. Y equals parentheses x plus 1 times x minus 3. Now remember, intercept form is y equals a times x minus p times x minus q, and that gives us our intercepts, then the positive value. So our intercepts are opposite of whatever the sign is that's here. So these ones first want you to give the intercepts because that's how we're going to graph them. We're going to graph it with intercepts, and then you have to find the vertex, which is also where your axis of symmetry is going to be after that. So my x-intercepts are going to be at opposite sign, so -1 and +3. So when I graph it, it'll be when y is equal to 0, I graph those 2 points. So that's going to give you the 2 points that you would normally be finding mathematically, and instead now we have to find the vertex mathematically, basically. So our vertex, it's p plus q over 2. So it's whatever our intercepts are, so the signs that are on the intercept, so opposite whatever's up here. We write them down. So -1 plus 3 over 2, which ends up being 2 over 2 is equal to 1. So the x value of my vertex is 1. I would have to plug this back in up here to find the y value. So if I plug it in, I've got y equals, parentheses, 1 plus 1 times 1 minus 3. So that's 2 times -2, which is -4. So my vertex is at 1, -4. Actually, I'm going to move this over so I can write my graph. There. So then my axis of symmetry is at x equals 1. And now I have everything that I need to be able to graph it. So axis of symmetry, so dotted line at 1, x equals 1. I've got a vertex at 1, -4. Then I have x-intercepts, so that's the points on the x-axis at -1 and 3. And notice that both of those are 2 away from my axis of symmetry, so that's another way to check and make sure you had it right. If they're not 2 away, something's wrong. Or, well, I say not 2 away. If they're not identical on both sides, then something's wrong. And then just connect the dots.
I'm confused.
About what part?
How you got like the 2 dots?
So these are the intercepts that I found initially. So this is in intercept form, so it has to be in the x, obviously with the a, x minus p times x minus q. So when we write our x-intercepts, according to just the standard rule of whatever it's supposed to be, the intercepts are at p and q. If the signs don't match, then we have to change the sign on them.
Well, I did that part. I just don't know, like, the graphing part was confusing me.
So x-intercepts are where they occur when y equals 0. So we stay on the x-axis to graph those points. So we just went to when x is -1 and y is 0, and we put a point. And then when x is 3 and y is 0, we put the other one. So technically, if you wanted to write it this way, you have a point at -1, 0, and a point at 3, 0. That's technically what those 2 points are.
Can I go back then?
Will there be anywhere y doesn't equal 0 at all?
What do you mean?
Would they give us any in intercept form where there are no points where y equals 0?
No, because it couldn't be an intercept form then. And the other thing is like, let's say that you are just really, really struggling with intercept form. What you can do is you can actually FOIL this and get it in standard form and then proceed. However, it wants the x-intercepts, so you're just going to have to find them like more manually if you are struggling with this. Or if you wanted to go and check it and make sure you did it right, you could essentially graph a side by side and make sure it works. So, let's see, 16. Y equals 2 times x minus 5 times x minus 1. Josh sounds like he's dying on us. All right, so where are my x-intercepts? Yep. Yes, at 5 and at 1, because this is in the form it's supposed to be in, and it's opposite signs of whatever's written there. So I need to find my vertex. So it's at P plus Q over 2, so 5 plus 1 over 2, which is 3. So that's the x value. I'm going to plug 3 into the original to solve, so y equals 2 times 3 minus 5 times 3 minus 1. So 2 times negative 2 times 2, which is negative 8. So my vertex is at 3, negative 8, meaning my axis of symmetry is where?
3.
X equals 3. So now I can set this up to graph it. Keep in mind that you need to go all the way down to negative 8 on the y, so just be mindful of that when you're drawing your graph. And is this one opening up or down?
Up.
Okay, up. So I've got my axis of symmetry at x equals 3, so I'm going to have a dotted line there. So my vertex is at 3, negative 8. My x-intercepts are at 5 and 1. So when y equals 0, I have x equals 1 as a point, and I have x equals 5 as a point. Notice those are both 2 away from my axis of symmetry, so that's good. Any questions about this form? Do you need to see another one? Are we good? All right, so the next problems are to write the function in standard form, which is just foiling, which is, like I was mentioning a minute ago, the way that you can graph something like this. If you're struggling with intercept form, you can always like change it to standard form and graph it that way. So just some basically foiling practice. Number 24, y equals x plus 4 times x plus 3. So remember, we do FOIL first, outside, inside, last. Now, I don't always do it in this order. A lot of times I actually flip the I and the O. My math teacher used to call it FI-oil. So technically it doesn't matter as long as you have accomplished multiplying all 4 of these things that I have drawn little arcs to, then you're good. So first we've got x times x. So that's x squared. Then I've got x times 3, which is 3x. Plus, and then I go to the next one. So 4 times x is 4x. Plus, the last one's 4 times 3, which is 12. And then you just combine like terms. So x squared plus 7x plus 12. So that's all these ones are asking you to do, is to just change them into standard form. Another one of these, number 26, h of x, so that's just another way to represent y, it doesn't matter what the y value, if you will, is, equals 4 times x plus 1 times x minus 6. So you can do this one of two ways. You can either go ahead and distribute first and then FOIL, or you can FOIL and then distribute. I usually FOIL and then distribute. So just make sure you don't forget to write down the 4 when you go to do that. And then I usually will do a bracket, since I will have to simplify what's inside the bracket before I multiply. So x times x is x squared. Outside, x times negative 6 is negative 6x. Then inside, 1 times x is just plus x. Then the last one's 1 times negative 6 is negative 6. So then I can combine the like terms inside. So 4 times x squared minus 5x minus 6. And then we just multiply the 4 all the way through. So 4x squared minus 20x minus 24. Does that all ring a bell? Foiling, all that good stuff. Awesome. All right, I'm going to do one more of these that it just looks a little bit different the way that it's set up. So number 30, g of x equals negative parentheses x plus 6, and that whole thing gets squared. So the parentheses is getting squared plus 10. So this would be one that's given to you in Vertex form. So if you're struggling with Vertex form, you can multiply that through and get it in standard form, and then do the standard form method, if you were just so inclined to do that. So this says that this whole parentheses is being squared, meaning I would write it twice. Okay, it doesn't mean each thing in there is getting squared. That's a common mistake. People will be like, oh, I'll just throw the squared on both of those. I'll just distribute the squared. That's not true. False information. So we keep the negative sign. Then we have x plus 6 times x plus 6. And then when that's all said and done, we add the 10. So we're going to FOIL first, then multiply the negative sign through, then add the 10. So keep the negative sign. I'm going to do the bracket again since I've got other stuff going on. So I've got x squared plus 6x plus another 6x plus 6 times 6 is 36. And then outside of my bracket, I have the plus 10. Okay, and I do that so that I don't get confused and put the negative sign all the way through to that. That's why I bracket it off like that. So then combine like terms. We've got negative times x squared plus 12x plus 36 plus 10. So then we're going to multiply the negative through all the way across. Well, let me rephrase. All the way across what's in the bracket. So we have negative x squared minus 12x minus 36 plus 10. And then now I can combine the negative 36 and the 10 to give you negative x squared minus 12x minus 26. So any questions about any of these? Ready to try some? So 3, 5, 13, 21, 25, 27, and 31.